Hey guys, this is virtual day number 8, and we are starting unit 5. It's looking like we're going to be at this a little longer than the 2 weeks, maybe 3, maybe 4, who knows. So I'm just going to start going with it. I'm going to start doing a day at a time, and hopefully after this week, we're going to move one lesson per day like we normally would. I have decided that the only grades I'm going to take, as long as we're doing virtual day, are going to be quiz and test grades. So please make sure that you are getting those done and turning them in. And just like normal, your test, if it's better than your quiz, will replace your quiz grade. So that's going to be our start for quarter 4. Please email me if you have any questions. Remember, my email is amandac@tcsnc.org. And the grades are due for me this morning, so please make sure that everything has been turned in. Email me if you have something come up and you need an incomplete, and we can chat about that depending on the situation. Okay. So we're going to start with quadratic and power functions. So this is way back. Quadratic functions, this is standard form, y equals ax squared plus bx plus c. A, B, and C are real numbers, and A is not 0. If A were 0, then it would be a linear equation. The domain for all quadratics is all real numbers. If A is greater than 0, so if it is positive, it opens upward, and it's going to look like this, a parabola. And if it's negative, it's going to open downward and look like that. The axis of symmetry, also the x value of your vertex, or h, if you remember the vertex form, x equals negative b over 2a. So the easiest way whenever we're finding the vertex and the axis of symmetry is to complete the square, which we did a little bit of in the last unit with our circle equations when we were converting from polar to Cartesian form. So this equation, I'm going to complete the square and put it in vertex form. If you remember, that vertex form is y equals a times x minus h squared plus k. So this guy, I'm going to say equals 2x squared plus 8x plus something plus my 5 minus that same something. So what I do in order to not change my equation, I have to add it to this piece and subtract it. Otherwise, it fundamentally changes the problem. So my first step is always to get my GCF out of this piece, and I always put this piece in parentheses. I think it makes it easier to know that this is what I'm working with here. So I'm going to take my GCF out here. So I have 2, and that does not include the x because this one is going to be a constant. And then I'll have x squared plus 4x plus something plus my 5 minus, and then whatever I've done here, I have to say 2 times whatever I'm putting in there. You always have to take your GCF out before you can find your square, complete your square. So remember, to complete the square, you take your b term, b over 2, and square it. So we've got 4 over 2 squared, which is 2 squared, which is 4. So I got 4 in both of these places. Feel free to hit pause at any time to catch up if I'm going too fast for you. I'm just trying to get this done in the shortest video possible. So I have 2. And then what this is, I can factor this guy, factors of 4 that give you 4, right, which would be 2 and 2. To get positive, you just have x plus 2, x plus 2. Or you can just know that whenever you divide it by 2, whatever this number is right here, that is going to be what goes inside with your x. So you're going to have x, that's positive 2, so plus 2 squared. 5 minus 2 times 4 is 8, so 5 minus 8 is 3. So this is vertex form of this equation. This means that my vertex, remember h and k, you always flip that sign of h, so it's negative 2, and leave the sign of k, 3. And your axis of symmetry is the x value of your vertex, so x equals negative 2. You can get more points by going on your calculator and looking at the table. So I'm just going to start with these. I'm going to graph here. And my vertex is negative 2, positive 3. Looks like I graphed it wrong. Let me get a little white out here. I need my x-axis to go down some. Sorry about that. -2, positive. Oh, wait, no, it is -3. Look what I did. 5 minus 8 gives you -3, not +3. So I'll do that. There we go. I was right with my intuition there. Let me get this. 5 minus 8 is -3, so now that's a negative. And my vertex is at -2, -3, so I'm going down 1, 2, 3. This is positive, so it's going to open upward. You can find more points on your calculator if you just type it into your equation. Y equals, and you can type in your original or your vertex form. I would type in both just to make sure that I've done my vertex form correctly. X plus 2 squared minus 3. Oh, shoot. Sorry. Need to adjust my window here. 6. And there we go. So now I'm going to look at my table. They're both, they should graph. You should only see one graph if you graph them both in there. Look at my table and you can get some values. So I've got, I have -2, -3. I have -1, -1, and -3, -1. I have 0, 5, which is going to be my y-intercept. When it's in standard form, C is always your y-intercept. Just a note. I'm not going to graph it that high, so I'm just going to do this over here. And there we go. My axis of symmetry, sometimes I'll graph that in there, and that would be this line here, x equals -2. Your vertex is HK, where H is -b/2a, and K is f of h. That's the way I'm going to denote it in your practice homework. K is f of h. So whatever you find h to be. Again, if a is greater than 0, the vertex is a minimum. That's your lowest point because it's opening upward. If it is greater than, or I'm sorry, I think I said it backwards. If it's greater than 0, it's a minimum because it's opening upward. If it is less than 0, it's a maximum because it is opening downward. So locate the vertex without graphing. So you have two options here. You can complete the square, which is what I'm going to do, just trying to practice that. Or you can use this formula. Plug in, find h, and then plug h into your equation to find your k. So I'm going to complete the square. So I have f of x, and I've got -3x squared plus 6x plus something plus 1 minus that something. Take out my GCF between these two terms without the x. So that's just -3, and then I have x squared minus 2x, still going to be plus something, plus 1 minus, now I'm going to have -3 times my something. So then you're dividing, you take your b term, divide it by 2 and square it. So -2 divided by 2 squared is -1 squared is 1. So you have -3 out here, x minus 1 squared. And then this negative becomes a positive. 1 plus 3 is 4, so plus 4. So that means my vertex is 1, 4. You always flip the sign of h and leave the sign of k. Your x-intercepts, so when it's asking you to find your x-intercepts, if the discriminant, so remember the quadratic formula? Quadratic formula is -b plus and minus the square root of b squared minus 4ac all over 2a. So that's where this comes from. The discriminant is what's underneath the radical in the quadratic formula. If the discriminant is greater than 0, then it's going to have two different x-intercepts. If it's equal to 0, then it has one where it touches. That would be multiplicity 2, which means it touches at that, and that's going to be your max or min. And then if it is less than 0, then you have no x-intercepts or non-real answers because you cannot take the square root of a number. So we're going to look at that. We're going to graph this by finding the vertex, the axis of symmetry, and the intercepts. So I always start when I'm in standard form like this by noting that this is my y-intercept. So that kind of helps us graph. So I'm just going to go over here and make some notes. I've got y equals 1. That's my y-intercept. And then I'm going to put this into vertex form, and I believe, I'm not being mistaken, it's the same one we just did. So this is the same as number 2. So we've already put this in vertex form, so I'm going to just rewrite what we did there. F of x equals -3 times x minus 1 squared plus 4. So my vertex, we said earlier, was 1, 4. My axis of symmetry, that's the x value of my vertex, x equals 1. And now we need to find our x-intercepts. So this is easier, in my opinion, when it is in either factored form or vertex form. Factored form, you can use the zero product property, set each piece equal to 0 and solve that way. Vertex form, you can just solve this whole guy. Set the whole thing equal to 0, solve it, and it gives you everything. This works for everything. So you can also find it on your calculator. I'm going to go ahead and just set this equal to 0 and show you how to do that. So -3 x minus 1 squared plus 4. So I'm going to subtract 4 from both sides. -4 equals -3 times x minus 1 squared. Divide both sides by -3. And you have 4/3 equals x minus 1 squared. Then you're going to take the square root. When you're solving an equation and you take the square root, you take the positive and negative square root. So I have plus and minus the square root of 4/3 equals x minus 1. You can drop the parentheses there, so I'm just going to add that 1 to both sides. And you have x equals 1 plus and minus the square root of 4/3, which is about, and you're going to do both of these in your calculators. 4/3 is not a perfect square, 4 is, but then you'd have the 3 on the bottom with the radical, and you'd have to rationalize. All I want are the approximations. So 1 plus the square root of 4/3, 2.15, 1 minus the square root of 4/3, -0.15. So I've got x equals 2.15 and -0.15. And then I'm just going to graph this down. So over 1, up 1, 2, 3, 4. We're going down because of that negative, so it's opening downward. We have the y-intercept of 1 because of my axis of symmetry. I know that this is also going to be 1 over here at 2. And then I have my x-intercepts at 2.15 and my y-intercept at -0.15 right there. And then there we go, something like that. Always check it on your calculator. You can find these on your calculator. So if you go and type it in and then do second trace, and option 2 is zeros, you're going to go left bound, right bound, enter, and that'll give you those values. The next one, I'm going to show you the H and K version here instead of giving you the vertex form. I'm just going to find the vertex. So H equals -b over 2a. So just remember that formula. So I've got -6 over 2 times 1, which is 6 over 2, which is 3. And then k equals f of h, which is 3. So I'm just plugging that in. 3 squared minus 6 times 3 plus 9, and that gives you 0. So my vertex is 3, 0. This 9 is my y-intercept. My x-intercepts, so you can look at this because this is 3, 0. That's going to be your x-intercept, your y is 0. So my x-intercept is 3 because that's your vertex. There's only the 1. And my axis of symmetry is x equals 3, the x value there. So I'm just going to graph this guy. I'm at the point 3, 0. It's opening upward. I should have moved this axis down a little bit. This is my axis of symmetry. I know I have a y-intercept at 9. I'm just going to call this 9. So I've got a point here. And that's 1, 2, 3 over. So I'm going to have a point here as well. That's kind of a bad representation. But let me get a picture. Check my head there. Okay. All right, and then the next one. I'm going to use what the method we just used here and then the quadratic formula. You're welcome to use either method. I do not care. Whichever one you like better, completing the square and then solving to find your x-intercepts, or the HK and then plugging it into your calculator, factoring if possible. So this one, I'm going to use the HK. So H equals negative B and negative 1 over 2 times A, which is 2. So I have negative 1/4 or negative 0.25. Then I need f of that negative 0.25. And I have 2 times negative 0.25 squared plus negative 0.25 plus 1, which equals, type this in your calculator, 2 times negative 0.25 squared plus negative 0.25 plus 1, 0.875 or 7/8. So I'm going to leave it as a fraction because I think it's easier to graph it that way. So I have my vertex is at negative 0.25 and then 0.875. Now let's think about this just a little bit. If this is opening upward because it's positive and my vertex is at a y value that's greater than 1, I'm not going to have any x-intercepts. You can check this on your calculator. I'm going to show you how to do that with the quadratic formula, the discriminant. So remember, my y-intercept is 1. My axis of symmetry is the x value of my vertex. And then I'm going to use my discriminant to determine if there are any x-intercepts. So my discriminant, that is b squared minus 4ac, or what's underneath the radical on your quadratic formula. So I have 1 squared minus 4 times a, which is 2, times c, which is 1. You get 1 minus 8, which is negative 7. Because it is negative, there are no real x-intercepts or zeros. So now I'm going to graph this guy. I'm at, so if this is negative 1, I'm at negative 0.25, and I'm going to go ahead and graph my axis of symmetry. And if this is positive 1, I'm at 0.875, so I'm close there. And then my y-intercept is at 1. So if I go over to 1/2 here, then that is going to use my axis of symmetry to find that point. And there you go. You can find some more points on your calculator if you like. So the steps for graphing: option 1, complete the square to find the vertex and graph in stages, or use the vertex formula to find the vertex, determine the y-intercepts. Just use the discriminant in the quadratic formula to find your x-intercepts, and use the axis of symmetry to find another point. I like the completing the square the best. If I had to choose, that would be my favorite. And that is what we're going to do on the next one. Then we're going to look a little bit at 3.2 power functions. This is not too hard. Mostly it's just remembering end behavior. But let's do number 6 first. Graph a function when the vertex excuse me, is 1, -5, and another point is 0, -3. So I'm going to use vertex form. Y equals a times x minus h squared plus k. When I'm given the vertex, I'm given h and k. When I have another point, that's an x and y value. What I need, though, is my a value. I need to know my leading coefficient. So I'm going to use h and k and x and y to find my leading coefficient. So I'm just plugging these in to this equation. So y is -3, so I have -3 equals, I do not know a. That's what I'm solving for. X is 0 minus h, so -1 squared, and then plus k, k is -5. And I'm going to solve this equation for my a value. So add 5 to both sides. And you get 2 equals 0 minus 1 is -1. -1 squared is 1. So a, or -1a. If you need to simplify that further, that's fine. But a is 2. So your equation, y equals 2 times x minus 1 squared minus 5. This is the equation of your graph. So then we're just going to use this to graph it. We know this point, 0, y, this is our y-intercept, because our x value is 0 over our vertex. And now we can look to see if there are any x-intercepts. We can solve this equation, so that's what I'm going to do. I'm going to take this guy here, say 0 equals 2 times x minus 1 squared minus 5, or you can use the quadratic formula, totally up to you. Add 5 to both sides. 5 equals 2 times x minus 1 squared. Divide both sides by 2. 5 halves equals x minus 1 squared. Take the square root. Remember, you have to have the plus and minus square root. So positive and negative square root of 5 halves equals x minus 1. Add 1. You get x equals 1 plus and minus the square root of 5 over 2, which is about, plugging those in my calculator, 1 plus the square root of 5 over 2, 2.58. So about 2.6. I'm just going to round there for the 1 decimal place. 5 over 2. Negative 0.6. So those are my x-intercepts. So now I'm just going to sketch a graph over here. My vertex is, it already tells us I don't need to write this. 1, -5. That is also my axis of symmetry is going to be at negative or at positive 1. My y-intercept is -3, so I can use my axis of symmetry to plot that point as well. And then my x-intercepts, I have 2.6, so if that's 3, it's a little more than 2.5. And I have -0.6, so about right there. So this is going to be my graph. I'm not having good luck with hitting those points. All right. That is 3.1 for today. 3.2, power functions. We're just graphing in stages. Just remember that if n is an even integer, then your graph is going to look something like this, or this, something like that, some variation of a parabola. Okay, it can have some stuff in between, but the end behavior is going in the same direction. If it's an odd integer, it's going in the opposite direction. So if you just remember that, or you might have something like this. This will be a positive, and this will be a negative. These are both positive. Negative would look like this, right? So if you can just remember that even power goes in both directions, the end behavior goes in the same direction, and odd goes in opposite directions. So this guide to graph it in stages, you can look at the key online to see the total stages. I'm just going to tell you what's happening because this is what I expect you to do on your practice and homework, and then graph it that way. So first I want to reorder this because it's always going to be, it's going to tell it to you in the a x minus h to the n power and then plus k. So this is what it's going to look like. So I'm going to rewrite this. F of x equals negative x to the 5th plus 1. Please be careful with that. So we are reflecting because of the negative. And we are going up 1 because of that guy. That's k. So if it's to the 5th, then we know it's going to look like this. I'm reflecting, so it's going to switch sides like this. And it's going up 1, then I'm just shifting that guy up a little bit. So that's really it. So I'm going up 1, so that's my new center point. I'm reflecting. If you think about -1 to the 5th power, that is going to be -1, but the negative up front is going to make it a positive 1. That's why it's going down. So we're going up 1 from that point. And then here, -1 or +1 to the 5th power is 1, but it has a negative out front, so we're going down 1 from that point. This is what it's going to look like. You can also plug it in your calculator, especially now. I'm not going to take the calculator away from you. If you take 2 and make it to the 5th power, your next point is going to be at 32, and then +1, so it'll be 33, and then at -31. So those are, with those 3 points are going to be about the only ones you can graph. And then this last one is x to the 4th. So we know it's going to look like this. That 1/2 is going to compress it. Remember, if it's greater than 1, then it stretches. If it's between 0 and 1, it's a compression. And this guy is going to make us go right 1. So my original vertex is at the origin. I'm going right 1, so this is my new vertex. And I'm compressing. So normally 1 to the 4th power is 1, but half of that is going to be 1/2. Or I'm sorry, yeah, because -1 to the 4th power is +1, and then half of that is going to be half. And 1 to the 4th power is 1, half of that is going to be half. So the reason that I'm saying 1 here, or -1 here and 1 here, is because I have taken my original function and shifted it over. So I'm just subtracting that 1 from it. So if I plug in 0, 0 minus 1, that's -1. -1 to the 4th is 1, and then half of that is 1/2. You can also get these points on your calculator. The next points that you would come to, so if you take 2 to the 4th power, that's 16, and we're taking half of that, so that'd be to the 8th. So we have 8 would be our next point. When it says to find the power function in your calculator, there's one on your homework that you might just want to wait and do tomorrow. But it asks you to plug in the values, and these are the values. And when it says to find the power function, you're going to go to Stat Calc and go down to Power Regression and hit Enter until it comes up. And it will give you that. My diagnostic is on, so you can ignore the R squared and the R. All you need are the A and the B. So this is about 16x squared would be what that one would look like. So that is this one. So now you should be working on the practice and the homework. I've uploaded keys for those. I'm attaching those keys to our original outline. The original outline is linked to the COVID outline at the top of the page. I think the COVID outline is a better view of what you need to be doing and when. So just let me know whatever you need to look at. I'm updating both outlines. Thanks, guys. Have a great day.